Hello, welcome to this presentation where we want to look at some concepts under mensuration. And in this case, we want to look at a frustum of a cone. So what is a frustum? A frustum is a part which remains when the top part is cut off. All right, so if you have got a cone like this, suppose this is our cone, then we chop off the top part. So this part that will remain will be a frustum of a cone. If it is a pyramid, it will be frustum of a pyramid. All right, so our interest here is to see how we can find the volume of a frustum. But at times, you'll be required to find maybe the volume of a small cone, depending on the diagram that you've been given, or maybe even the radius. Okay, but now let's see what we are being asked to do here. We are saying the diagram below, or the diagram shows a beam, all right? B, C, D, E, which was made by cutting off a smaller cone, ABD, ADE, this one, to cut off this smaller cone. So whatever you're going to remain with is what we are calling a frustum. All right? Now, you have been told that, or we're able to see that the radius of this bigger cone is 8, whereas the radius of the smaller cone is 3. The height of the smaller cone is 9, but the height of the bigger cone is from here all the way up to 9. Right? We need to appreciate that. Now, what is the question? Let's calculate the value of h. Now, how do we get h? By using the concept of similarity, right? Because we know that shapes that are similar have got a constant ratio. So what I'm going to do is I'm going to compare two things, two cones. All right? I'm going to compare two cones here. Okay, two cones. All right? A smaller cone. Let me just redraw it nicely. I'm going to compare a smaller cone to this bigger cone so that you can see what we are talking about. Okay, this is our smaller cone. The height here is 9. The radius here is 3. So the height here is 9, but the radius here is 3. Now, if you deal with this bigger cone, maybe we can label first the smaller cone. It is A, E, D. This is our bigger cone. Now, we can come up with a bigger, smaller cone, sorry. We can come up with our bigger cone. Okay. So that you're able to see what is happening. Okay, something like that. So this is our bigger cone. Now, the height is from here all the way up to here. Now, look at our radius. This is like G. Our radius is 8. And this is the B, this is C, and this is our A. So from G to some point here, E, you've got E. we've been told that this is H, but from H to A, you can see from H to A, here it is what? 9. It is 9. From H to A, it is 9. So, meaning therefore that when you look at the EG, we don't know it is H. All right, so meaning that the height, if you look at the height, if you look at the AG, AG is going to be what? It's going to be H plus 9. But for this one, for the smaller one, if you look at AE, if this is the, F, this is F. Take note, this is F. F. AF, according to that smaller one, it is what? It is the 9. So this is a smaller height, and that is a bigger height. So we can say, we can use the height and the radius. That the height of a smaller cone is AF to the height of the bigger cone, it is the AG. Whatever ratio I'm going to get, it should be the same as the ratio for the radius. What is the radius of smaller cone? EF, and the radius of the bigger cone, GB. Okay, so what is our EF? It is 3 centimeters. How about AG? AG, we are saying it is H plus 9 centimeters. This is equal to EF, AF, sorry. I think AF is not correct. AF is 9. Okay, then EF is 3 centimeters. GB is what? 8 centimeters. Okay, so you can close multiply. You can get rid of the units, please, so that you don't get confused. You multiply. So what do you have? You're going to have 3 times H plus 9 is equal to 9 by 8. So I can divide by 3. I can divide by 3. So H plus 9 is equal to 9. 3 into 9 is 3. So 3 times 8. Okay, so H is equal to, or say H plus 9 is equal to 24. So H is equal to 24 minus 9. So H is equal to 15. So the height there is 15 centimeters. So the height of the frustum is 15 centimeters. It is 15 centimeters. 15 centimeters. Okay, the height here is 15 centimeters. 15 centimeters. And we are good to go. Then, okay, just a minute. Then, we find the volume of BCDE. BCDE, which is the frustum. So, the volume of a frustum is given by volume is equal to height of the frustum divided by 3 times area of the top part plus area of the bottom part plus the square root of area of the first part times area of the second part of the bottom part. Okay, just a minute. Okay, so in this case, what is our height? Our height of the first term, which we are talking about, this first term, this one. What is our height? We have found our height to be 15. Then, what is A1? So we look at the top part of the first term, and this is the base, or whichever. You can swap them, it's okay. So I'll look at this base, which is like a circle. So I'll apply the formula for the area of a circle, which is pi r squared, right? Equal that one for A2, it will be pi r squared, because again, here the shape is the form of a circle. So what that implies that A1 is equal to pi is this 3.142. Okay. Times our radius. What is the radius? So if I'm starting with A1 is this, then the radius is 3 squared. So you can get your calculator. You say 3.142 times 3 squared. You get 28.278. Then A2, the same because they are all circles. 3.142. The radius there is 8 squared. What do we get? We get 3.142 open bracket 8 squared. What do we get? 201.088. Okay, so if you want, you can even get A1 plus A1 in advance. It means we should just add these two. So I'll say 201.088 plus 28.278. We get 229.366. Again, we can get this if we want. Say A1 times A2. What are we going to get? So you multiply 28.278 by 201.088. What are we getting? Okay, we are getting 86.366.464. Okay, then we can substitute. All right, let me just erase this now. We can substitute. We can substitute. Okay, so okay, let's erase this part. Okay, so we are going to say this implies that our volume will be equal to our height is 15 divided by 3. Open bracket. What is the A1 plus? What is this? A1 plus A2. We've already found it here. So it is the 20.229.088. 366 plus the square root of what is A1 times A2? We have also found it here. 568, 6.36, 6464. Then you close here, you close your bracket. Then you punch now, you start with this, you punch its square root. So I'm going to say I punch the square root of that one. You're going to get 75.408. Then you add it to this, whatever answer you're going to get, add it to this one. So plus 229.366. What am I getting? So I've got V is equal to 15 over 3, open bracket, 304.774. Okay. Then this answer, you can multiply it with 15, then divide by 3. Or since we know that 3 into 15 is 5, you can multiply that answer by, so V is equal to, you multiply this answer by 5. So you multiply the answer by 5, so it will be by 5. So what do we get? We get 1523.87. So we can round it off to 3 significant figures. So 1, 2, 3, we cut here and take 3 as 0, 0 plus 2, we have got 2. Now, since there's one digit, one number before a point, we need to fix a 0 to the power 3. And this is your volume. Okay, thanks so much. This is where we end for this presentation. I hope I've managed to help you deal with the volume of a frustum. This formula is applicable to any frustum, whether it is of a pyramid or a cone. So in the next presentation, I think I'll talk about the pyramid, the volume of a pyramid. All right? Yeah. So please subscribe and share. Okay. Yeah, but before I forget, we have what we are calling a fast track program, which we have designed for the people that are writing their GCE exams this year, which is 2023. It is scheduled to start on the 10th of June. 10th of June, 2023 to the 8th of August, 2023, representing a duration of 2 months, and per month is the 500 kwacha. Meaning that the entire period, you just need to pay 1,000 kwacha. All right, where you can contact us via 0978 56 58 76, and you'll be able to reach to Mr. Phiri, who is myself. All right, and we'll be glad to help you. This is where we end. Till next time, shalom, shalom. This has been Phiri Kamban signing out.